everybody, and welcome to today's webinar from Wevolver. My name is Smair Jaber. I'm a tech writer and editor, and I will be your host for today's webinar. And today we'll be talking about Edge AI development from concept all the way to deployment. And we'll look at how ModelNova from embedUR accelerates this process. Now, if this is the first time you've joined the Wevolver webinar, allow me to give you a brief introduction about Wevolver. Now, Wevolver is a global platform, a global community used by engineers across the world to stay up to date about the latest technologies. And what engineers do on Wevolver is access informative and inspiring content, such as articles and videos and webinars like today on different topics like robotics, aerospace, advanced manufacturing, AI, and other state-of-the-art technologies. So every month, millions of engineers leverage Wevolver to stay up to date, to find the knowledge they need in developing their products and make meaningful connections with one another. Now that that's out of the way, before we jump and meet our guest today, just a bit of housekeeping. Feel free to introduce yourselves in the chat section. You can find the chat in the bottom there, and let us know why you're joining, what you're looking for. And if you have any questions throughout the webinar to our speakers, we will have a Q&A session at the end to discuss these. So feel free to put your questions into the questions section, and we'll get to them in the final 10 to 15 minutes. All right, now, without further ado, let's meet our guests. And with me today are two really interesting, really amazing speakers and experts. We have Eric Smiley and John Marconi from embedUR. I will let you guys introduce yourselves a bit more in a bit, but allow me to do a brief introduction first. Now, Eric is the VP of Business Development at embedUR. He helps connect embedUR's expertise with customers and partners in order to envision and develop intelligent connected solutions. And Eric has an undergraduate and a master's degree in electrical engineering from Duke University. And very interestingly, Eric has co-founded a Wi-Fi security startup to help secure wireless connectivity, which you'll probably tell us a bit about that, Eric, if you like. But for over a decade, Eric has worked as part of embedUR's uniquely experienced team, running the latest technology waves from Wi-Fi to cloud to IoT and now to Edge AI. So Eric, thank you for joining us.
Thank you very much, Smair, for that introduction. I think you told the audience basically everything they need to know. But again, my name's Eric. I've been with embedUR now, leading our business development efforts for the past 10 plus years. So I'm excited to be here with you today. Thank you again, Smair, for helping to host this discussion. I think it's a really exciting time in the industry. We're going through a unique transition of how products are envisioned, designed, and developed. And it's a unique transition for us as well to, to be a part of that growing ecosystem in Edge AI, which is what we're going to talk about today. Not much to say about the wireless security business, except we were a little bit ahead of our times when I started that back when I was at Duke way too many years ago. This was before Wi-Fi was really being used in the public much, let alone in some mission critical applications. And so me and a couple of my college friends saw a unique opportunity to really look at how can we secure Wi-Fi before wireless security was really even a standard thing, so that doctors and lawyers would be comfortable using Wi-Fi in their offices. We were a bit too early, but it was still a great experience and set me on a path of entrepreneurship, which has now led me through multiple companies and now here over the past 10 years at embedUR. Where we have had a storied, successful history of helping companies to build new technologies. So look forward to talking about Edge AI today, Smair. Thank you.
Awesome stuff, Eric. Thank you for that. And let's also meet John. So Mr. John Marconi, he's the VP of Technology at embedUR. And John is a seasoned technology leader with over 25 years of experience in designing, developing, and launching innovative products. And he has played a pivotal role in creating software solutions that have won awards, bridging low-level device drivers, embed systems, and scalable cloud architectures with big data and Edge AI innovations. And at embedUR, he leads the technology and architecture across the company, including their innovative ModelNova platform, which we'll talk about more today, and all the Agile initiatives. So John, thank you as well for being here.
Yeah, thanks, Smair. Thanks for having us. Yeah, this journey into Edge AI has been pretty amazing for myself as well as for embedUR, and we're excited to share what we've learned, as well as some of the tools and technology that we're making to try and help the whole industry move forward. So excited to be here today and talk about that.
Awesome, thank you. All right, well, let's get started. And before we start talking about the technology itself, I mean, it all starts with understanding a problem that's there or a bottleneck that's out there in the space. In your experience so far, what are the biggest development hurdles that you see teams, when they're trying to build and deploy Edge AI products? What do they go through that hold them back?
Well, Samir, I think even before we start talking about how we face challenges with the development, it's how do we face challenges in coming up with the ideas for what our customers in the industry want to build as products with integrating Edge AI.
Good point.
What I was mentioning earlier about kind of a change in the way that projects are envisioned, it used to be not so long ago that companies building IoT or connectivity products really had a good idea of what they could do with the underlying technology that they were using as the basis for their products. And of course, they know their customers and they know their use cases. And so they would come to the technology providers, such as the silicon companies and software innovators like us, with the ideas of what they wanted to move forward with to provide value to their customers. What we've seen evolving now is that the silicon and software providers have actually advanced even beyond what the use cases and ideas are. So the end customer and our customers, those that are building Edge AI products, aren't even 100% clear on what the possibilities are of what they can do with this technology. So one of the really cool things that John and his team have been able to do is to interface with our partners, the silicon companies, as well as with our customers, those building IoT and smart connected products, to really dream up what we can work on next. So that's the first challenge, is being able to see and demonstrate and prove what can be done on Edge AI products. Once you have that idea, then moving forward to building a productized solution that's going to add value to our customers, and to society, is really in bringing a whole bunch of multidisciplines together, which has always been the case in technology. Not one company can build everything that goes into a product, but that's even more so the case as what we're seeing with Edge AI. There are experts out there in building the models. There are experts in putting together data sets. And of course, there are embedded experts in making everything work on small devices. But the challenge that we've been seeing from our customers is that there isn't one group that has pulled all of that together yet, to really be able to take the product from idea to model to data sets to embedded platform to customer experience. And that's really where we have, built expertise over the past 20 years, is how do we build solutions from a whole bunch of building blocks. So that's really the biggest challenge I see, is bringing together the expertise needed from a whole bunch of disciplines in order to bring a product to market.
Really interesting stuff, Eric. John, anything to add from the technology side? Any particular
Yeah.
challenge?
Yeah, right. So I think one thing I would add is that the world is moving pretty fast, and Edge AI is moving even faster. So one thing that we see is that hardware companies are developing new solutions, right? They're trying to come up with the state-of-the-art accelerators and tools and everything to make their products stand out. And companies and startups and open organizations are creating new models that are also pushing the boundaries of what you can do on this hardware. So there's an interplay between what you can do today on this hardware keeps shifting. And so like even keeping up with the state of Edge AI is pretty challenging, because it's moving very rapidly. And there's a lot of fragmentation in the market that I think will settle out, as time goes on. But for right now, there's a lot of moving pieces, and it's something that we're trying to keep ahead of.
That's really interesting. I mean, Eric, you mentioned having that one platform that brings all of these together. So maybe we could talk a bit more about ModelNova. So could you maybe explain to us a bit what ModelNova is exactly and what makes it different from other AI development platforms?
Absolutely, Samir. That's a good question. So let me get there by talking about how did we come up with the idea for ModelNova, and what did we see as a gap in the ecosystem, giving us an opportunity to help to advance the development acceleration, if you will, the development of edge AI products. So embedUR over the past 20 years has worked together closely with silicon companies, internet service providers, and OEMs, building anything from wireless access points to doorbell cameras, and helping those companies to accelerate getting their products to market. And so we've built a lot of expertise in embedded technology. How do we make all of the peripherals connected to a CPU or a microcontroller work together with software, with sensors, in order to build a viable product that adds value to our customers? And while we started evolving into AI over the past 10 years and then into edge AI in the past 5 years or so, what we started to see was that while there was a wealth of content on the open market with regards to AI models, and maybe a little bit less so with data sets, but there was still open source content available for AI models. Those models were meant to be run on general purpose computers or even GPUs, high-end GPUs like from NVIDIA or others. And not everyone necessarily had access to those, let alone you're not going to be able to run a model that is tailored for a high-end processor like that on an edge device that may even be battery powered and definitely run by a small microcontroller. So we started taking the models that were publicly available, and our own team started porting those to our silicon partners' devices so that we could showcase to their customers what can be done. And what we were seeing was that even with our expertise, the work was challenging. It took a while to take a model from its original open source style and get it working on a small edge device. And we thought that this was going to be a stumbling block for many organizations who were trying to just start working in edge AI, and they might get dissuaded from building investment and putting budget aside to go build edge AI products. So we saw an opportunity to take the Model Zoo concept and focus it specifically on edge AI. And so ModelNova is a model zoo that pulls together content that is needed for building proofs of concepts and then products with AI on small edge devices. We take models that are commonly used in computer vision, computer audio, industrial, and other areas, and we pre-port those models to tiny devices, to edge microcontroller devices, for example, so that the open community has access to a model that's ready to go in minutes instead of weeks or months on an edge device. And then pair that together with embedUR's experience, we kind of just help customers to go from that ideation to prototype to productization.
Really, really interesting stuff. And I want to double click on the last point you mentioned, which is that sort of speeding up that development from weeks to minutes. How do you achieve that technically? I mean, do teams use the pre-trained models as they are? Do they typically fine-tune their models for specific use cases? And the question is to both of you in this case.
Right. So that's a great question. So we basically have curated our data sets and our models to essentially like the most common use cases. So we want to see, what are the types of AI deployments that most people want to use, and see if we can get that running on their device really quickly. So one of the challenges that we see, so there is the AI model part, which is obviously complex. And that's usually the part that's a different world from, a lot of embedded development. But then there's also integrating that model into the hardware. So there's pre-processing, post-processing, fitting it into RAM, fitting it into flash, all these different, integrating it with the sensors on the device. All these different aspects of actually getting the model on there can be quite complex in themselves. And then you have to actually get the model running. And so, part of what we're doing with ModelNova is also providing those recipes for, okay, I've got the model now. I've got a YOLO V8 or whatnot, and I want to put it on my device. But how do I integrate? Where are the C++ libraries for this? How do I fit it into my SRAM? How do I get the best performance? And so we're trying to make that aspect of it also very easy for users. So even regardless of getting the model, getting it onto the device integrated with the sensors and everything is something we want to accelerate to the point where somebody can pick these things up, essentially click a button or two and get up and running and say, there it is, it's running, and see their hardware light up.
Really, really interesting. I mean, it's all really like if you think about it, the technical part of it, the technical side of it, you need to consider power constraints. You need to consider performance levels. You need to consider cost efficiencies, et cetera, and all of these are trade-offs. I mean, across Edge AI in general, right? How do you how does ModelNova support developers in making these decisions between these different factors here?
That's a really good point, Smair, especially since, as I was mentioning earlier, a lot of the models that are openly available today are not built with those constraints because the advancements of CPUs and GPUs to be able to process AI inferencing is so advanced today that you don't necessarily have to optimize the models for performance because the underlying hardware is so capable. And that's one of the things that John and his team have become experts in, is how do you take a model that was designed to run in a very powerful, unresource constrained environment and modify that model by, quantizing the weights, by adjusting the layers, by even removing some parts of the model as appropriate, while still focusing on building something that's accurate and serves the use case to be able to run on a small battery constrained microcontroller. A lot of these microcontrollers that we're working with have embedded NPUs or neural processing units that are in effect mini GPUs, is the best way to think of them. They are AI accelerators that can sit alongside of microcontrollers, and a lot of our silicon partners have been launching products in the past year in that arena, and these are really exciting solutions, but they are still resource constrained in order to fit into these small battery powered devices. So John, I know that's a lot of the work that our team has been working on. What are some of the main areas that we've had to focus on and the expertise we've had to build and drive that into ModelNova to help our customers accelerate getting these products running on edge devices?
Yeah, you're right. So one of the key pieces that I don't think we've really discussed much is we have a set of metrics for the different models. So you can kind of think of when you run one of these AI models, you're loading it up into the NPU. You're going to run it. It's going to do something. It's going to detect people in the image. It's going to detect audio, noise. But when you're on these constrained devices, how long does it take to run, and how much power is it using? So we have a section of ModelNova that actually we benchmark the metrics for these models. So we say, okay, if you run this on this device, you'll find that this particular model, for every image that comes in, it'll take half of a second to run, and it'll take this many joules of power to run. So what happens is, when you are choosing how you want your system to run, especially with battery powered devices, you have a set of requirements. Okay, I need to process 10 frames a second or 60 frames per second or whatever. And ModelNova makes some of that selection process easier to select like some of the image sizes that you might pass in, as well as select models that can fit into your constrained budget for your device. So you basically, it's an auto selector. So you can go and choose the things that are going to work and not have to waste time trying to figure that out yourself. So that's one of the key benefits that we have.
Really interesting. I mean, could ModelNova be used as a testing ground, so before finalizing a product? So can a team experiment with different deployment targets, for instance, right? And going through, I don't know, considering a low power MCU or you know, performance focused edge box, etc. What kind of capabilities does a team have when it comes to experimenting around on ModelNova?
Right.
Exactly. Yeah, go ahead, John, please.
Yeah, I was going to say, so one of the things that we want to make easy is that experimentation process, right? So it's as easy to deploy one POC as it is to deploy 10 POCs with different models, right? So even though we provide metrics and you can see the accuracy scores, you can see how much memory it takes, but there's something very different about actually running every one of the models on your device and seeing how does it actually perform and interact with the sensors and what kind of outputs you're getting. You know, some of these models operate, you know, better in different lighting conditions, or they operate better with, you know, the distance at which people are from the camera. So some of those, you know, essentially like differences that don't come out in the base metrics of performance are very important to every use case. And so being able to try a variety is also very helpful to users who want to experiment.
Exactly. And not just try a variety of models, but on a variety of platforms, as you mentioned, as well as you're experimenting with, you know, what platforms, what peripherals make the most sense for your product. And instead of having to have your development team go through and port the model, like I said, could take weeks or even months of effort for each individual platform, not just by differences of the microcontroller, but the peripherals that might be on that test platform. That's something that, you know, ModelNova could help accelerate if it's a supported platform. Another thing about ModelNova too is that it's not just a handful of models. I think we're up to 70 or more models on the platform today, and there'll be over 100 by the end of the year. So the breadth of use cases that you can support from ModelNova is growing every day. So another thing we considered was adding a feature on the site that we call Try It Now. And so that's a way that you can, through your own web browser, see what at least a computer vision model, because those are easy to use your computer, your laptop camera for, and your browser to see what does this model actually do before you take that step of moving it to hardware and then seeing how it performs and work on training it and so on. So again, the whole concept here is to really just help a group of developers to accelerate building a proof of concept, and then taking that next step to getting that project funded to move forward and build the solution internally to take it to market more quickly.
While you're talking about that, I mean, what's the question that is in my mind is about the data, the curated data that is being collected and put in there. How do these data sets fit into the workflow? Well, what kind of setup is there? I mean, John, if you can.
Yeah, right. So you're absolutely right. So the data sets that you train these models on is extremely important to every use case. So like I was mentioning earlier, like we've kind of chosen some you know, very widespread data sets that are, you know, cover a lot of use cases. For instance, Cocoa data set from Microsoft. It basically covers, you know, 80 different classes of objects, from people to bicycles to various types of food. And so like you can quickly get that up and running. But, you know, if you have, let's say you wanted to deploy an object detection for, you know, a type of, you know, screw in your factory. Well, you're not going to find data sets that are going to be, you know, good for that, you know, easily, because your screw may be very unique to your manufacturing process. You may even manufacture your screw. So the idea here is that we get the user started with some good data sets, and we're building our data sets, you know, continuously. So we want to essentially, you know, have starter options for if you wanted to build a smart city application. You need a different data set than if you wanted to build something for person detection. And so like over time, we're curating these data sets to build up, you know, basically solutions for use cases across different verticals. And then there's these ones that you finally are going to select, you know, if you're building the industrial camera that has something very specific, that's where you come in and actually build your own data set or get one from the manufacturer and start, essentially like retraining your model to do that specific use case.
Interesting. Eric, anything to add on that?
Well, I think data sets are probably one of the afterthoughts, but it is incredibly important, as John mentioned. If you don't have a good input of data to train the model, your model's not going to be accurate. It's not going to solve the use case that you want. And as John mentioned, while there are plenty of open source public data sets, those data sets are incredibly large. Hard to train in many cases, hard to train a model that's going to be trying to fit onto an edge resource constrained device with a public data set like that. And so we can, work to curate the data that's very important for a particular use case, and also work with some of our partners that are innovating in the area of synthetic data. So that's with the advent of advancing generative AI and tools around that, there are opportunities to take a small data set, maybe you have a handful of images, but use synthetic generative AI data generation in order to expand that data set for other areas. Like John was mentioning, screws, for example. So if we're in an industrial environment and your goal of a camera is to look and see, are the screws that are going into your products, are they damaged? Are the threads correct? Are they screwed in the right distance, for example? Because sometimes that's really important with tolerances of different products, and you want to be able to automate that process. But who's going to have a data set of every type of possibility of what the problem cases are for screws? So you could work with us and our partners in order to build synthetic data that is generating images of the different possibilities of what some air conditions might be, and then use that data to train the model, deploy the model, and then retrain the model when it's in the field once you're collecting more information of the accuracy of the model.
Really, really interesting. I mean, we've talked about the data, we've talked about the trade-offs, we've talked about the models in general, and like the 70 so models that you have already on ModelNova. Who is ModelNova built for? Who's going to be using this, right? Is it a specific type of startups? Is it OEMs? Is it specific innovation teams, or is it all of the above?
That's a really good question. And there's multiple groups that could benefit from ModelNova, starting with the silicon companies themselves. The silicon companies are innovating very quickly, as John mentioned, and launching microcontrollers rapidly that have integrated neural processing units for enabling edge AI scenarios. And their customers, like I said before, may not have the experience as to what you can do with those devices. So the silicon companies want a quick mechanism for their potential customers to be able to evaluate what can be done and what the performance will be on these particular silicon devices. So our silicon partners are benefiting from ModelNova in order to enable their customers with libraries of use cases that they can, even before the proof of concept phase, use as an evaluation of what we can do with a particular silicon platform. And then the next step in the development life cycle is, as an OEM, someone who's building a widget, a smart doorbell camera, a security system, a industrial weather camera or audio or other form of sensor system to be able to detect anomalies in manufacturing, for example. They need something to start prototyping from. And again, they can benefit from ModelNova once they've selected a platform, to take a model and get it on their platform and start experimenting with and then collecting data for their end productization, and then use ModelNova together with embedUR's expertise to then take that product further to production. John, does that line up with what you're seeing as you're working internally with our teams and with our customers?
Yeah, absolutely. I mean, we basically want this platform to be very open. We're adding functionality to it all the time. Eventually, we want it to be more community driven. So bring in data sets that are popular from not just our own team, but from others who want to contribute something that's useful. And so for that, we have to build up a great ecosystem of partners, across enterprises, across academics, across people who are kind of just home hackers, that they want to see how can they run the model on this device that they just bought from DigiKey. And that's our idea, is like we want to get everybody involved and kind of like getting their hardware up and running, and getting smiles on their faces, and getting them connected to the silicon partners who essentially like want to sell more chips and showcase what they can do on their hardware.
Really, really.
John, you bring up a good a point about some of the what we call challenges that we've been running on the ModelNova site. So you can go to ModelNova, and we occasionally will have contests that we call challenges, where if you're a tinkerer or a college student working on your PhD, or someone who's working at a company who's evaluating and experimenting with Edge AI products, you can utilize the content on ModelNova and our challenges in order to hone in your skills, and then submit back to the community your modified model or your modified data set, and maybe even have the opportunity of winning something from us. And so that's something that we've actually partnered with the Edge AI Foundation on as well. We have a version of ModelNova that's running under the Edge AI Foundation site that they refer to as Edge AI Labs. And that's really a community-driven organization. And you'll see on Edge AI Labs even more challenges, both with models and data sets. So we definitely invite you to check out those challenges, and you'll see those advertised from us and from Edge AI Foundation in the coming months for new ones.
Really, really interesting, Eric. I mean, I should probably try it for myself and see if I can get something going there. But I mean, you mentioned silicon partners there, and you mentioned all of these different integrations, and that brings the question of compatibility, more precisely hardware compatibility. And we know that that is a challenge in edge development generally. So how does your platform address that challenge?
That's a good question. So the freely available ModelNova site that's available today, all of the models have been ported with pre-trained models onto Raspberry Pi, as that is a very easily accessible, rather inexpensive platform that everybody can get their hands on. And so that is the primary platform today for a user of ModelNova to be able to try out these Edge AI use cases and applications, and experiment with what their end use case could be before they move on to an actual silicon MCU platform for building their custom device. We're then working with our silicon partners to launch bespoke versions of ModelNova that would be through their development platforms, so that silicon companies' customers on their development platforms would be able to access either all or a subset of the ModelNova models that have been ported to those custom platforms. And that's how we allow the ModelNova community to start with something like Raspberry Pi to experiment with what can be done, and then through the silicon partners that we're working with, get access to those models ported to those common platforms, those specific custom platforms. John, I'm sure a lot of the time that your team has spent on ModelNova has been through our partnerships with the silicon companies, and figuring out what all the intricacies and differences are with each of those platforms to take these models from Raspberry Pi and move them to the individual hardware platforms. Is that right?
Yeah, that's exactly right. Because every one of these NPUs and end devices, they essentially have their own tool set that you need to convert these models into something that can run on their hardware. And so one of the challenges with that is that not all these tools accept the same formats. So some models are in Onyx format, some models are in TF Lite, some models need ExecuTorch. And the NPUs also, and the tools that supply the model into the NPU also have their own requirements. And so we see that like part of the effort that we actually spend per platform is to take these models that are kind of coming from the open source community and get them converted and ported and running on each one of the different MCU architectures and their NPUs, along with the tool set. So, as you go from silicon to silicon, what you find is that the SDKs are different, the operating system, if there is one, is different. The tools to convert the models are different. The amount of memory is different. So we want to kind of take all of that complexity away from somebody who just wants to run their model, see how it works, take all that complexity away, also give them the source code that they need to actually implement this on their platform, and get this up and running right away on their device. So that's part of what we spend a lot of our time on, is just integrating with these different devices.
And the goal is really to take that work away from our customers, from the silicon companies' customers, so that again they can more quickly get these devices from idea to production. As IoT started to grow and develop, I think one of the challenges was customer adoption, and one of the challenges was how do we find use cases that really add value to the end user. With Edge AI, there's some really slick stuff that our team and our partners in the ecosystem are working on. And our goal now is how do we get that out to the customer? How do we start adding value so that when I wake up in the morning and go to my coffee pot, it knows who I am and makes the right style of coffee for me, versus when my wife walks up to it, it makes the right style of coffee for her in a private way that doesn't invade on my privacy. I know this device is probably going to have a camera or some sort of sensor, but I don't want that data going back to a cloud. I want all of that processing happening right there on the edge, making the device intelligent. And so the coffee pot can make its decision without having to store my face. The same can be applied to security cameras and doorbell cameras, or as we were talking about earlier, to industrial environments. Such as making sure that manufacturing is streamlined, operational expenses of the manufacturing companies are reduced by using AI on these simple edge devices, but in an advanced way to really just add more value to the process. So again, our primary goal here is how do we build up that library of material that helps to accelerate that process of getting these products really deployed and used.
Yeah, and one other thing to add to that is, so we're doing this for end users, right? Somebody who wants to just get their device running. But one of our ideas also is that even the silicon partners, they only have limited time and budget to kind of create some of these example solutions on their hardware. So what we see is that every company has a model zoo of some number of models and example source code that they've kind of put out there to promote their chip. But they really don't necessarily want to be in the market of providing the AI models that their customers use. It's essentially software, and these guys want to sell chips and not the software solution. So part of what we do is we come in, we get their hardware, and we provide all of the framework and the models and everything that can go onto the silicon right away, so that it kind of lowers the overall investment from the silicon partners, and it makes it much easier to see a large variety of use cases come to life on their chip without them really having to invest much in their own engineering team to do this.
Really, really interesting stuff. I mean, we've talked about all of that, but now what I want to have from each of you, at least your view to the next 2 years, 3 years. How do you see Edge AI evolving? What's next for ModelNova in this space as well? What can you tell us? Starting with you, Eric.
Thank you, Smair. This has been a great discussion so far, and I look forward to hearing some questions from the attendees. So, just as a little plug, as you guys are listening to us, if you start having some questions, please, start putting those out there to us on the chat, so that we can spend a few minutes at the end talking through those. But the future of Edge AI is really an open path. It's for us and the ecosystem and our customers and their customers to help define. I was just reading about a new product that's going to be launching next year that I'll probably be an early adopter of. But to be able to put a camera system in my yard to look at wildlife and be able to tell me what is in my backyard, the birds, the bugs, the bees, the flowers. And this product was pretty darn slick. It not only tells me what's in the environment in my backyard, but it even narrates to me almost in a documentary style and short little video clips of what took place in the big wide world of my backyard. And all of that can be done from a camera. Now think about the AI that goes into that. Obviously, you need to be able to do object detection and understand, is this a flower? Is this a tree? What kind of flower? What kind of bug? So that's a really unique data set that you're probably not going to find in the open community. And so where I think one of the areas that's going to be a big focus is on the data sets. Obviously, you need the model, you need it integrated on hardware, and that's a big part of what we're working on now. But one of the future areas that I think is going to need a lot of innovation is in the data sets, like we were talking about earlier with combining real world imagery and audio together with synthetic data. And that's an area that we're working on partnering with various startups and other companies out there to bring that content onto ModelNova, so that these companies that are out there building the next generation products, whatever they dream up of, we can help them to quickly find the right model, integrate it on their hardware platform, and then build the appropriate data set so that I can tell when my ladybug is crawling on this type of leaf and what it's doing to help pollinate my backyard, just as one unique example. Obviously, that doesn't provide a lot of value to society, but you can imagine where you can go from there for similar types of products that really can help make my life easier as I walk into my home and in a secure, private way, have my home know about what's happening in the environment, know about where I'm coming from, what I'm going to do next, and set up my environment accordingly to make my life a little bit easier.
That's just
John, what are
amazing.
your thoughts?
Yeah.
Yeah, I mean, actually, I know you said that that's not a very useful use case, but I think if I had some camera that could tell my kids if there's wasps in the yard, they would definitely love that.
Yeah.
Rather than finding it out for themselves. But yeah, so I think that like I said, there's a lot of investment and movement in both the model side and the device side. And we actually, as a company, maybe about 2.5, 3 years ago, we were asking every one of our customers, "Hey, what is your plans with Edge AI? What is your plans with AI in your systems?" And they all said, "Yeah, they're looking at it, but they're not sure what to do. It's on their roadmap, but they don't know." And I think that message over the last year has really changed. Where okay, this is actually something strategic that we need to do, and I'd say maybe 50% of the companies know what they want to do and 50% are still not sure. I think that what we're seeing is as more of these use cases get deployed, as the technology becomes easier to kind of like incorporate into everyday products, we're seeing a lot more companies are adopting it. And I think the use cases and the usage of it is just exploding. With that said, the whole Edge AI concept started with really tiny devices, and it kind of moved on to things with cameras, and now a lot of the excitement is doing Gen AI and doing LLMs on your device. It wasn't a year ago, it really wasn't even possible. And now we're seeing hardware coming out that you can actually talk to your device and it doesn't send anything to the cloud. It'll hear what you said. It'll come up with some response, and then it'll respond back to you in your language. And that, personalization of your devices, whatever it might be, is going to drive a whole new industry of, smart edge devices that, we couldn't have imagined a year ago. So it's pretty interesting how it's evolving. And I think every year it's going to keep evolving until we run out of things to innovate on, which is going to be, never.
We'll never do that, right? There's always going to be more to innovate. But I mean, thank you, Eric, thank you, John, for really insightful stuff and really interesting points you mentioned there. Before we jump to Q&A, do you have any final thoughts you would like to share before we start looking at the questions?
Well, what I'd like to say, Smair, is thank you again to you and to the Wevolver team. It was exciting being a part of generating the Edge AI report that you published a couple of months back. And we definitely appreciate the time here to talk to the community. And we invite people to check out ModelNova. It's easy to remember at modelnova.ai, and you can sign up for an absolutely free account in order to view and access those models. And start running them on Raspberry Pi today. And feel free to reach out to us if you have any questions or problems with running the models on your platform as you're experimenting, or even if you just have ideas of where we should go next. What is that next use case that you or your team are working on, and you'd like to see coming on ModelNova, or a platform you'd like to see us to integrate with. So, like we were just talking about, I think the future is wide open with AI. I think that Edge AI is really going to be that thing that makes IoT even more successful. IoT had the goal of connecting everything, and now Edge AI has the goal of making everything intelligent at the edge. I think it's just going to make the overall experience of interacting with technology more seamless and open up use cases that we haven't even dreamed of yet, while at the same time it's going to have the unique side effect of reducing some network load to our network backbones. So maybe I'll be able to stream that sporting event on Netflix or YouTube a little bit more smoothly, since my doorbell cameras and my neighbor's doorbell cameras will be having to send all these images to the cloud and processing because they can all happen at the edge. So I'm personally excited to see where we can take this next. And I know that John and his team are investing quite a bit into where the future of edge AI is, and you're going to start seeing more of that on ModelNova. John, I don't know if you have any additional thoughts to that.
Yeah, thanks, Rick. Yeah, and please reach out to us. So, as Eric mentioned, we're part of the Edge AI Foundation, and it's a pretty cool group of companies that have all come together for this common purpose of advancing Edge AI research and products and use cases and things like that. And so please reach out to us if you have any questions or any ideas or any if you're not sure about how to create the next thing that you want to create. We'd love to hear your ideas and kind of give you some suggestions and from our experience, and it helps us all grow as a community. So yeah, we're excited to hear from everybody.
Awesome. Thank you so much. And as Eric mentioned, a couple of months ago, we launched the 2025 Edge AI Technology Report with embedUR featured in that as well. So thank you guys also for contributing to that. But a lot of the audience members might have come to this webinar through that report. If you haven't, please go check it out. It's the link is shared in the chat as well. It's really insightful. There's a lot of insight from so many different experts in this space. So go check it out. It's worth reading. But then again, thank you for the great conversation. Let's check out the questions for the last 10 or so minutes before we run out of time. And I have a question here around security, and it's the security of the public models. And this person is asking, like, who's liable for downloading a public model for production use, or even if it's fine-tuned. This person wants to know how embedUR works to control this so-called security.
It's a good question. I can take it from the policy side, and then John can talk a little bit more about how we are working forward with security and future areas for AI and for models. But most of, if not all of, I think the models on ModelNova today come from public sources. And these are open source models that are coming from their own licenses. So wherever the source of the model is, we'll have a use case license attached to it. And so on ModelNova, we link to that use case, to that policy. Many of these models can be used in commercial projects, and many of them cannot. And so we follow and adhere to the license that the model was originally published. The same applies to datasets. And then you'll be able to see those licenses on ModelNova. So all of the content that's on ModelNova is freely available for download and use and experimentation. Some of them might have more strict use policies than others with regards to the licenses. But then, of course, there's securing the model itself on the platform. And this is something that we work with each of our customers on as they're building their products, because it's very dependent upon the hardware and the way that the model and the weights are stored on the platform. But John, I don't know if you have anything else to say about the use cases, the terms and policies on the site, as well as how we're securing things on edge platforms.
Right. So just in terms of the models themselves, I kind of think of the models as being two parts. One of them is maybe three parts. One of them is the source code for the model, right? So everything came from some kind of, Python source code or C source code or something. So these open models mean open source, essentially. Those models have a license that you need to adhere to, and it could restrict how you use the model. It could restrict how you train it, how you run inference, like what kind of devices you can use, things like that, how you deploy it. But also when you take a data set, so if I take, again, like the ImageNet data set as an example, it also has its own license. So it's one thing to take that data set and use it, but once you combine that data set with your model, you actually have this paired up set of two things together. So the data set and the model that you've trained now become paired in a way that you actually need to follow both licenses for the data set and the model. So that's one key thing is when you go to ModelNova, if you download any of our models, it'll basically let you select from multiple data sets that it may be trained on. And when you select those things, you can actually see the license for both the data set and the model, so you know what it is you can do with this. So that's a very important thing to understand. And again, like there's a lot of open data sets out there that are basically for academic and research use only. So you have to think about what it is you want to use this for. If you want to use it for a product that you're going to sell, or if you just want to use it for, you know, creating your own solution for your backyard, it depends on what you can do with it. In terms of security, so definitely we don't intend to control the open data sets or the open models. So what we typically do is we take these open source baselined at some version and the data set baselined at some version, and we combine them. We're not really controlling the security of that aspect of it. We also intend that the models you get from ModelNova are kind of like proof of concept models. So essentially, you take this model, you have to agree to whatever license if you want to use it. But we're not really in the business of selling or controlling what you do with this model, or even securing it. So that would be something that end customer would need to do if they wanted to essentially take this into production. With that said, we do have other things we do as a company to do model security, basically building things to identify, basically validate the models are, valid for the platform, that they're haven't been changed or modified by some third party. Basically the whole life cycle over securing what went into the model binaries themselves, and make sure that all of that is, secured and well controlled. But it's kind of a separate service that we do from ModelNova itself.
Thank you for that answer. I think it's really interesting. I have another question here. I mean, you kind of alluded to this a bit when you were talking about the models and datasets, but how would I pick what model is best for a use case that I have? How can I identify the optimal model for myself in on a ModelNova platform?
That's a really good question. And like I said earlier, there's, I think over 70 models right now on ModelNova. A lot of those are computer vision. There's some computer audio models up there as well. And we're just going to keep adding to the Model Zoo content. I think that's one of the values of ModelNova is that it's not just a one and done. It's not just a small number of models with examples in different use case areas. It's really a growing library of many different types of computer vision, of computer audio, and other models. So you're right, it might be a little bit overwhelming at first if you go and you find, 55 video models. How do I pick which one is the right one for my application? So we've put information on ModelNova. With each model, there's a description of what the model does, what data set it's trained on, and some example use cases. And many of those models have the try it now feature that I mentioned earlier, where within your browser, you can see what the expected output of the model is to see if it meets what your use case is. Another thing that we didn't even touch on ModelNova is something that we call blueprints. And there are a handful of blueprints on the site that go a little bit deeper, almost like a knowledge base, into how do you pair together a model with a data set with an application to create a product. So things like trash sorting or face recognition for doorbell cameras, we'll create different blueprints, basically almost like a blog to give you an idea of what you would need to pull together for that particular use case. And so if anybody out there in the community has an idea of a particular use case and you're not sure where to start, please reach out to us on ModelNova and we can help to eventually build a blueprint to fit that use case. John, what are your thoughts on how we go about the process? If a customer comes to us and says they want to build a an application that's going to look at a trash can and decide which, whether it's recycling or, natural waste or food waste. How do we decide, what model is going to make the most sense for that?
Yeah, I mean, so I think you're right. So there again, there's a lot of different components that go into that. So let's say we're talking about sorting trash. Is this trash coming along a conveyor belt at a recycling plant that's moving very fast, where you basically need to make split-second decisions on what's happening? Or is it something like you can take like half a second to kind of take a look at what's in a picture and then make some decision based on that? So some of the metrics are built into the site today. There's also some work that we're doing to essentially like fine tune the selection. So for instance, like I think I mentioned before, some models may work better with like low light situations, or they may work better with the distance, that it can detect certain things in the image. Basically, how small is the object in the image? So those type of things don't come out when you just look at, you essentially need to go out on, and do research on the web and talk to people and figure out like, what do they use to solve this problem? And they may say, hey, go use this model. So we essentially we do a lot of experiments when we're developing products to kind of hand select the models that we feel are best for that given use case, which can be very different based on your use case. We want to basically add some of that information into the site and also help users. These are the kind of use cases I want to do it for. Can you help me select one? So that's something that we're building in soon to basically help users find what they should use as a starting point.
Thanks for that answer. And we still got 4 minutes, so we can squeeze one more question. And I mean, you've talked about the stuff that are on ModelNova to explain the models and all that aspects. What is the difference with ModelNova content compared to other models out there, right? Where there's Hugging Face and other models. So what differences can you share with us that sort of make ModelNova content unique?
Thanks, Smair. I think one of the main differences is what led to the reason for us creating ModelNova in the first place. Hugging Face is a great library and repository of many models. It's a huge library. It's supported by the open community, and you can probably find just about any AI model that you're looking for on that site. But as I mentioned, those models almost exclusively are built at their core to be run on a general purpose processor, whether that's your desktop, your laptop, or even a GPU. And they're not optimized for running on an edge platform. And there's a lot of work that goes into not just optimizing the model so that it can run on a resource constrained and performance constrained microcontroller, but to integrate with a edge operating system. So a lot of these models are expected to run in a Linux environment or even a Windows environment. Getting them to run on a RTOS or on even a bare metal type application involves conversion, involves making the model fit into the tool set that's needed to be compiled and run on the microcontroller and be understood by the microcontroller's NPU and fit into its set of resources, its set of variables that it can support. And so the whole idea with ModelNova is to take content like what is available on Hugging Face and make it work on those small devices. John can explain a bit more about the technology behind that, but really that whole concept of going from the model that you want to getting it running on the platform in minutes versus having to work your way through getting it running on even a Raspberry Pi, let alone a microcontroller, can take a lot of work. Isn't that true, John?
Yeah, that is true. And so we basically, the whole idea of ModelNova is we want to curate that experience to specifically edge devices and kind of take away the whole, how do I convert from PyTorch into TF Lite? How do I convert from TensorFlow to an Onyx model. So essentially we do all of that work in the background to do the, basically the training of the model with the data sets, the conversion into the different formats, the quantization to kind of get it optimally working on your NPU. And then basically the validation on every device. We want to do all of that work, kind of take that out of the hands of the user to experiment, and then, get them up and running quickly.
Eric Smiley, John Marconi, thank you so much for this really, really enjoyable conversation. I learned a lot, and I'm sure a lot of our audience as well. I will definitely go check out and try to sign up to ModelNova and see if I can do anything myself, but I'm sure there are a lot of more experts who would love to work with that as well. But thank you so much. This has been really lovely to listen to and learn from you guys. And thank you to the audience also for joining us and listening to us. And I really look forward to another conversation like this one. Hopefully we can talk more about blueprints as well, which is a really interesting topic there. But I just want to say thank you. Great conversation. Appreciate it.
Thank you, Smair. Definitely appreciate it. And I'm excited to see what we build next together.
Yeah, thank you, Smair. And looking forward to seeing you in the challenge that we have next.
Absolutely. I look forward to that as well. Thank you, everybody. Have a nice day.
Thanks.
Right. Bye.